Hey everyone, welcome back to another video of mine, where today we're going to be solving Leetcode problem 53 titled Maximum Subarray. So we're given an integer array nums, and we simply need to find the subarray with the largest sum and return that corresponding sum. Pretty simple and pretty concise problem statement, but it is definitely not a very easy problem at first. Unless you know the algorithm that's behind it, which I will be going over shortly in this video. So in example 1, we have a nums input array of -2, 1, -3, 4, -1, 2, 1, -5, and 4. And our output would be 6, because the subarray that actually has the largest sum that's embedded within this input is going to have a sum of 6, which in this case is going to be 4, -1, 2, and 1. And that's going to have a largest sum of 6. In examples 2, we have a nums input array of literally just length 1, with of course just one element that is equal to 1. And so our output would be 1, because the subarray with the greatest element is literally just going to be the subarray that contains that sole element, which in this case is going to be 1. And so that would be the sum, or the number, that we'd output in this case. And applying that same logic to an example 3, we would output 23, because the subarray that has the largest sum is going to be the subarray itself, which is going to have a subarray of 23. So note that the input can actually be a subarray of itself. For example, if I had the array of like 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 is considered a subarray or subset of itself, right? So that's also something important to consider if we ever reach cases like that. So before I actually give you guys a few seconds, and you feel free to pause the video to think of a solution yourself, I'm actually going to just give you guys one quick tip or hint of how to actually go about this problem. Note that when we have negatives in our subarray, all they do is just hurt our array, or hurt our current sum. And what that kind of means is all they do is basically subtract or make our current sum for this window smaller than it can optimally be. Right? We basically want to avoid as many negatives as possible. For example, in 4, 2, -1, 2, 1, the -1 literally just subtracts our total sum from this subarray by 1. It's just doing more harm than it is good. In fact, it isn't doing any good, but only harm. And so you have to actually keep track of that, right? When you're looking at negatives and adding that to a current or total sum that you're monitoring through all of your different subarrays, it's important to consider the optimality of this code and say, hey, when we're adding negative elements to our current sum, we really don't need to do that, right? That's not necessary. Okay, we could optimize our code by basically setting it equal to 0, and I'll explain that a little bit longer as we get through the code. So I'll give you guys a few minutes or seconds to kind of go over this problem in your head and think of a solution. And if you guys can't think of one, that's completely fine. I will tell you guys how I would optimally solve this problem in a bit. Okay, so basically before I actually start coding this up, there's actually a very, very common, popular technical interview algorithm behind this that's asking a lot of different technical interviews, and that's actually known as, let me just comment that out, the cadence algorithm. And this is a very common algorithm asked in a lot of different technical interviews, and so it's a very good one to know. And in complete honesty, you won't really use this outside of any technical interviews that you actually interview for at any big tech companies, and so it's really only used in these interviews, but it's still a very good algorithm to know to actually pass in the very good likely chance that you're going to get asked this algorithm. So, like I was talking about before, negatives are just bad for our array and take away from the total optimized current sum that we want to add for one specific subarray that we're currently adding or looking at in one specific iteration of our nums input array. So in Cadence algorithm, you actually have kind of two different variables. One is going to store the current sum that you're looking at for one specific subarray or one specific iteration of the input, while the total is basically going to store the maximum value or maximum possible subarray sum that is stored eventually in our basically total array, or total variable rather. Sorry. So I'm going to set total to be initialized to the maximum value of nums. Right? And of course, total at first is literally just going to be set to one specific element, but it's eventually going to have the largest sum of the subarray with that largest corresponding sum within our input. So ultimately, I'm going to be returning total, and I'll maximize it using our current sum that we actually add to during the iteration of our input, and kind of just validating it to check how optimized we can make it for one specific iteration. And of course, the current sum is going to contain all the different possible subarray sums that we can have, and so it's obviously not going to be completely optimized all the time, and we're going to optimize it in the total sum using that variable. So I'm going to set current basically equal to 0, because of course we haven't actually scanned through the array, and so there is no current sum if we don't actually have any elements or values to add that to. Okay, and to kind of just recap, what the total variable actually does is it basically just initializes total to the maximum element in the array. And this is actually very crucial, because if all of the elements in nums are actually negative, the largest subarray sum would simply be the largest or least negative element, or basically the element that's closest to 0. And what our current does is it basically initializes that to 0, right, as you can see on line 5. And this variable will just basically, like I said before, keep track of the sum of the current subarray as we actually iterate through the input array nums. And of course, we'll start with 0 because we will build this subarray, or this current sum, from scratch as we actually iterate or go through the input array nums. So now that we have that out of the way, let's actually loop through all the different elements in nums. We don't really need to work with indices here, because indices are not really important in this problem, but rather just maximizing the most profitable sum. And so we'll just say for I in nums rather than for I in the range of length of the nums. And this is where we kind of have our validation or checking conditional. Like I said before, if our current is actually less than 0, then we basically have to start fresh and kind of just start fresh and start building a new array without any negative elements, or with the least amount of negative elements as possible. So we'll just reset current to be 0, right? And so what this basically does is, if the current subarray sum is negative, we just reset it to 0. And that's because if a negative subarray sum is going to reduce the total sum of any future subarrays, it's just always better to start fresh with a sum of 0 for the next element in that specific iteration of the current subarray sum that we're looking at. Right? And out of this conditional, while it's actually not less than 0, we can literally just say we'll say current plus equals I. We'll just basically add all the elements to the current sum while it's actually not less than 0. And if it ever hits less than 0, we can just optimize it by resetting it back to 0 and starting fresh and building up from a new array to minimize the number of negative elements that we can have to optimize the maximum subarray sum that we can actually get. Right? And at the end of this, once we actually add each element for one specific iteration to our current subarray sum, we have to set the total equal to the maximum value of course, itself, the total or maximum subarray sum that we've recorded so far for every iteration that we've done so far within this problem, and of course the maximum value of itself and current, basically the current maximum subarray sum that we're looking at for this specific iteration to actually check if it's greater than any larger or maximum subarray sum that we've recorded so far in any prior or previous iterations. And once we've done that, that's basically the end of the code, and we can simply return total. So unless I made any syntax errors here, this should be completely fine, and it should be accepted. And as you can see, it is accepted with a runtime complexity of big O of n, because we really only scan through the array once, and so this is going to be a linear time solution. And I forgot to explain this line of code here on line 13. We simply return total, because total will eventually store the maximum value of every single possible maximum subarray sum, as denoted by cur. Right? And so once we return that, it will ultimately have, or basically store, like I said before, the maximum sum for any subarray that's actually valid, that's within the bounds of our input array nums. So to kind of just go over this code, like an overall explanation, what the contains algorithm is really designed to do is it's designed to find, like I said, the maximum sum of a contiguous subarray in a list of integers, right? Note that a subarray is defined to be contiguous, but it is also a very important keyword to look for while actually iterating through the list while keeping track of two things, right? The current subarray sum, basically set to cur, or the cur variable in this case, is going to be built up by adding elements as you actually iterate through every single element in the input array nums. And the maximum subarray sum, basically total in this case, is going to be updated whenever you find a subarray sum with the largest sum that you've recorded so far. And the algorithm basically resets the current sum to 0 when the sum actually goes negative, as carrying forward a negative subarray would simply reduce the chance of finding a larger sum in the future subarrays. And of course, if all the numbers in the array are negative, total is already initialized to the largest number or the maximum element in our integer array nums, and so that's going to ensure that we have the most optimized subarray with the largest sum, as we set it equal to the maximum of nums. Right? And like I said before, this is a linear time approach, or basically big O of n, because we really scan through the input array nums just once, right? And just to kind of show you guys a little bit more tidbit of how this code actually works, I can actually set total to also be nums at 0, right? Because at the end of the day, I'm still storing it to the maximum value of current, which stores every single possible subarray sum within our input for every iteration that we actually scan through the input array nums for, right? So eventually, once I hit cur to be the maximum value of nums for whatever iteration or whatever index that's actually in, I can reset total to be that maximum value, and so I don't really need to set it to the maximum value of nums. And so if I were to submit this again, this still would be completely fine, and it still would be accepted, but that's just how this code really works, right? And so, yeah, that's basically the contains algorithm for you guys. If you guys enjoyed it, please consider liking this video and subscribing to my channel. It really does help a lot, and it really does motivate me to keep going and keep posting new content onto this channel. But without further ado, I hope you guys learned something new and liked this video. And if you did, I will see you guys in the next video. Bye-bye.